All right, so welcome to class today. Blackboard wasn't working in my office, but it is working here. So I didn't upload everything, but I got a different plan to do that. Anyway, I have uploaded just a few announcements. I've uploaded last week's lecture, but I haven't made the link. So if you know how to get to the YouTube channel that creates them, you can get to it. I will put the links up there. Today's lecture is being recorded now. I don't have, like I said, it wasn't working in my office, so I do not have the link for today's material, but I'll put that up there too as we proceed through or not. So the last one there is last week's, and there's no YouTube link. But if you go to the YouTube channel, it is there. Week 11, part 1 and part 2. So I need to create the links so that it'll go up there. All right. Last week we started talking about doing GIS operations on the internet. So up to this point, we've put like maps on the internet. We've done it in a few different ways. We've put data up on the internet that's geographic data. We put that up on the internet. And we've kind of like shown different ways to click and kind of get information back. But we haven't done any GIS operations. So for anybody that wasn't here last week, what we mean by GIS operations are things like overlay and answering a GIS question, like maybe doing a buffer and then doing an overlay to answer a question. How many of these features are within 1,000 yards of this other feature, or 1,000 meters from this other feature? That's a GIS operation. And so today we're going to continue that discussion. And just as another announcement, this is the last week of new material being presented in this course. So no more new material. Next week, I think on the schedule I originally had, and I'll revise it, I originally had the presentation starting next week maybe, but we'll push that back one more week. And next week I'll just help anybody that needs help on their projects. I would also like you to send me emails asking for help as well. But we'll save that time and to do that. So there won't be any new material presented next week is what I'm trying to say. All right. Yeah. Question? Right.
Is that correct? Like in the time frame, it says you're going to present next week.
Mm-hmm.
But in the development of the project, it says something like in this paper is due December 9th. But our class is going to be over there, right?
So next week's the 29th.
Yeah.
And then,
and I think our final is
right, for the 6th. And then the 9th, yeah, I was going to make it due the 9th, but when do finals end? The week after that? So we could, even though the last class period, since it's a night class, is the 6th, we could make that due sometime in here. I just have to have it. I'll go and look at what day I have to have the grades turned in, and I'll make it due like a day before, or 2 days before that. So, yeah, I'll have some more information on the test next week. But what I'm probably going to end up doing is making the test kind of like you email it to me, and then we'll just do presentations on the 6th, since that is the last week of class. So I think that'll work out better for the format of the class. Yeah, we have 2 more meeting periods, and then the paper you do somewhere in here. I think I said the 9th originally, but I'll find out what the last day is, make it do a little bit before that. There's not that many students, so I should be able to grade them pretty quickly. All right, so that's schedule. I'll update the syllabus. Before you got here, I was explaining that for some reason Blackboard didn't work for me for like the last couple hours. I was trying to upload some stuff and it didn't. I could upload it to YouTube, but not Blackboard. All right. So today we're going to do. We're going to talk about doing some GIS operations, basically creating a service for GIS operations. In other words, we created a map service, but what if we wanted to do a buffer or overlay on the server? We could say, okay, this is the input, here's the process, and the output could be sent back to the client and displayed on the client. So, to do that, I should put the link there, but I couldn't. So, go to ESRI leaflet, Google that. And for me, it's the second one, the one that says ESRI leaflet, this one. This one is actually the code. And then hit the examples. So what we're going to do today is we're going to do both the front end and the back end. We're going to start with a front end example. I'll tell you how it works. And then we'll create our own back end version, and then we'll modify the front end example so that it works with our back end. So we're going to do some stuff in ArcMap, and we're going to do some stuff just with JavaScript. But we haven't really highlighted this before, but these are a bunch of examples for using ESRI map services in Leaflet. Okay. There is one here called geoprocessing, and that's the example we're going to look at right now. So I had meant to just provide a link to here. I could put that in here real quick, and course materials. Seems like it's still going. Link to example. All right, so I've created a link here. I should have called that week. Well, I didn't even call last week anything. So it says geoprocessing operations right there. Oh, before I get too far, this is I guess week 12. Just making sure that it'll save this and not right over the cartography. Just like this. Web mapping. Okay, so now that'll call that the right thing. Okay, so I put the link right there to the example that we're going to be starting with. So I'm going to just do what it says here. So this is a leaflet map that ESRI's created for their example, similar to the way we've put leaflet maps on our page. And if you notice that they provide a little instruction. So they just have a little div tag that they placed above the map. And it says, click on the map to calculate the 1 and 2 minute drive time polygons. So I'm going to do that. By the way, what city is this? Anybody know? It's not San Diego. No. But it's a good guess. It's California actually has a relatively few find natural harbors. Like on the East Coast, there's way more natural harbors. New York, and, yeah. So this is San Francisco, another one of the few natural harbors on the West Coast. But this says Golden Gate. That might have been a clue. Anyway, that's the Golden Gate Bridge. This is San Francisco. So I'm going to click right here. It does say working up in the corner. There's no indication of what's going on. But now, what it's created are two polygons. And these polygons are the 1 and 2 minute drive time polygons. Now, there's no way, at least there's no current way, there may someday be a way, but there's no current way that these drive time polygons could be calculated in a web browser. The amount of data that would be necessary to do that wouldn't be able to be sent over and displayed and even stored in a web browser, because a street network is a very complicated thing. In fact, we rarely build our own custom street networks anymore. This is something like in a GIS system that's typically outsourced to a large company. So the networks, the street network for the United States is housed, Google has their own copy. There's a few other companies that have their own copy, but a lot of the underlying data comes from other companies like Tel Atlas, and I think they've got, looks like they've got an OpenStreetMap contributions here. So my point is that data wouldn't be housed in the browser, especially since this example actually works anywhere in the United States. The default is San Francisco, but I could come down here. I'll do the coast. Could come down here and click a point somewhere near the Golf Park campus. So that's, can't tell exactly where that would be, but I'll just put a point down right there. Now it's going to click the 1 and 2 minute drive time polygons for the Mississippi Golf Park campus, or at least somewhere near it. I'm not sure if I clicked on exactly where it is. So what's happening, if we look at the code, this code is just setting up the map itself, like we have in our other examples. But from here down, okay, this is the base map. From here down, we're actually building we're actually requesting we're setting up what we call a geoprocessing service. In other words, a geoprocessing service is a GIS operation that's been set to run every time a request is made. You can have a URL associated with your geoprocessing service once it's published. In other words, in ArcMap, you create your geoprocessing service, and then you publish your geoprocessing service in ArcMap, and you publish it to a server, and at that point, when you want to do a GIS operation, your geoprocessing service waits for a request to this URL. In fact, we can copy and paste this URL here. Control C. We can copy and paste that URL. This is the URL for this drive time polygon service. And you can see the parameters that it's setting up. I'm going to show you how to do that. We've got our input location. We've got a drive time, which is just a string that it wants. In other words, it wants a value like 5, 10. So by default, it's giving it a 1 and a 2 in the development that was created. And then finally, there's the output value. Now, I realize that not every one of you have used a GIS system extensively, particularly ArcGIS. But I'm going to ask a question. Who here has used Model Builder before in ArcGIS? You've used Model Builder a little bit. Anybody on the coast use Model Builder? A little bit? Okay, so The way that this was created is in Model Builder. So we'll have a tutorial on Model Builder. There's a lot of help inside ArcGIS in order to do this. Okay? But the assignment will be pretty straightforward. We'll build the ArcGIS geoprocessing service together, and then the assignment will be to modify the example here in order to take advantage of the service that we create. So this is what it's asking for. And then there's a button down here. There's a way to execute a task. In other words, there's a URL set up to actually send the request off to the server. So you give it a URL, you give it the input location and the drive times, and the response that is returned is the polygon that represents how far you can get in 1 minute and 2 minutes. All right, in order to explore this a little bit further, what I want to do is go back to this example and copy this example in its entirety. So go from HTML all the way down to the close of the HTML loop, or the close of the HTML tag, and say copy. And then open that up in Notepad or Notepad++, whichever one you have. It'll look a little better in Notepad++, either one. All right? So I've copied all that down into Notepad, and I'm going to save this. I'm going to say File, Save As. And in Notepad, I've got to change this text document to all files. And I'm going to put it in the directory I've been working on most of the semester. You're free to put it wherever you want. CWM. And then I'm just going to call this I'm going to call it GP service.html. And then I'm going to hit save. And after I save it, I'm going to go to that same location and open it up in a web browser too. Oh. Okay. Yes, I pressed the button. I was too eager. I pressed the button. Kept coming up. Okay. So I'm gonna open this in the web browser, and now it's the same thing. Same thing as before. It's going slow. I'm just make sure this is still recording. Good. All right. So if I hit enter, if I hit a button, it will work and do that. Okay. More tools, developer tools. I want to see the network that's happening as I click. So if I'm going to click here, it's running this. It's sending off this URL. So I'm going to open that up in a new window. So it's having this URL. It's sending that off, and this is the response that it got. In other words, it sent off an input location, which was basically a point. And the ESRI leaflet took care of forming this point correctly. And then it also expected that what do you call it? The distances, the distance polygons, the drive times. So it's 1 and 2 are the drive time polygons that it created. And all this data, all this GeoJSON, those are just the individual vertices that describe the polygon that came back. So the processing was done on the server fairly quickly and returned. So if I go back to my example here, let's say I wanted to do 5-minute polygons and 10-minute polygons instead of 1 and 2. I can change it there. I can also change it here just so that the user will know that this isn't vital. go back over to this page, and if I refresh it, now my polygon should get larger even if I hit the same area. Probably taking a few minutes longer because it has to go further. So these are the 5 and 10-minute polygons. I could do 20, 30-minute polygons or whatever. By the way, what tool is this that's running? What extension is it that's running on our GIS server that's actually creating these polygons? Anybody know what the name of it is? You probably didn't use these unless you took 417. Anybody here took 417? The new 417, not the old 417. 417 up until about a year ago or 2 years ago was 217. But anyway, 417 is the vector GIS course. So anyway, this is Network Analyst that's running. So Network Analyst is run to create these polygons. The service that we're going to create is much simpler. Okay? It's not going to run this complicated process. Because it is a complicated process to figure out how far you can get on a street. It's not the most complicated thing in the world, but on a street network. That's what this is doing. We put a dot down. This is saying I can get to all of these areas in this polygon in 5 minutes. I can get to all of these areas in this polygon in 10 minutes. It's like a service area, or it could help in emergency planning, things like that. Okay, let's see if there's anything else that we could change. We wouldn't really want to change the dot, but one thing I do want to do is do a console.log, and then I'm going to log the value that's passed as the input location, which is right there. So that's the lat long, the input location. The drive times is one of the input parameters. The input location is the other input parameter. I'll refresh this page. This time I'm going to switch over to the console before I hit click. You can see it's a pretty simple JSON object that is the latitude and the longitude of the point that was clicked on the map. Let's see how far we can get from. There's Hattiesburg. From the Hattiesburg campus in 5. So we're about right there. No, right there. So from right where we are on the Hattiesburg campus, these are the places we could get in 10 minutes. I think it's a little optimistic. Maybe that's probably assumed that we were sitting in a car at that location. We could get good ways north of town. And yeah, that's pretty optimistic, especially out west of town in Hattiesburg, right? Especially about this time of day, 5:30, pretty lots of traffic. But you know, they're estimates based on the speed limits and things like that. All right. So it's a pretty simple example, but it's powerful because it shows that we can do a GIS operation. In this case, a network analyst operation to create those drive time polygons. So we're gonna change this a little bit. We're going to change it so that when the user clicks on the map, it's just going to do a simple buffer. That's the first one we're going to do. So when the user clicks on the map, it's going to buffer that. Now we actually demonstrated how we could do that in Turf. So that's not completely useful, but that'll give us an idea of how to build the back end. And then we'll change it, we'll modify it so that we click and it will buffer and cut out do an overlay with the USA data that I showed before, and it'll give us an estimate of all the people that live inside that area. So we'll do those two examples. First, we'll just do the plain old buffer so that we know what's happening. All right. So to do that, we do that in ArcGIS. So we'll modify this example so when we click, all right, ArcGIS, taking a few seconds to open here. Okay. So Leaflet likes the data, any data that's sent or returned, it prefers that to be in latitude, longitude. The EPSG code for that is 4326. So we're going to use that most of the time rather than the Web Mercator 3857. Now, you could make the geoprocessing service return a new map service if you wanted to, and there are some cases where you'd want to do that. In those cases, you would use latitude and longitude probably as the 3857 Web Mercator, so that it wouldn't have to reproject the data or the image. But for latitude, longitude, we're going to use 4326. All right, so this is Arc Toolbox. Now, even if you haven't used Model Builder before, there's probably a few more of you, maybe not everybody, but probably a few more of you that have used Arc Toolbox. Arc Toolbox is a set of GIS operations that can be done, that can be used to operate on GIS data layers. Okay? In order to reference my map correctly, to know where I am in the world, I'm going to add that USA layer that we were using before. I don't know if did I upload that, but look at my counties. Did I put that up on Blackboard before, or did I just say I was?
Week 8.
Week 8. Okay. So if you all want to download that, it's called CartLab right here. Yep, I thought I did. But this is mostly for reference purposes, so at least for now. And when we do the buffer and say, okay, how many people live inside that buffer, then we'll use the second layer. But for the first one, where we're just going to create the buffer, it's just for reference purposes, so we know where we are in the world. Okay, so I've loaded that layer up there. Now I'm going to create my geoprocessing service. And to create my geoprocessing service, I need to make my own tool in Arc Toolbox. Because what you do to create a geoprocessing service is that you create a tool in Arc Toolbox, and then you publish that tool, then you run that tool. First you run it, make sure it works, and once you run it and it works, you publish it as a service. So those are the 3 steps. You create your tool, you run your tool, you publish your tool, and then you can use it inside of ESRI Leaflet. Okay, so to create your own new toolbox, you can just say, so if you say add toolbox here, it's going to be looking for a toolbox. I'm going to go to I got to go to the same directory I've been working on, which is CWM. And there's no toolbox there. I haven't created one yet. So there's a little icon right here that will create a new toolbox. I'm just going to call that web mapping. I'm going to call the name of my toolbox web mapping. So I created a new toolbox. And I renamed it. And if I hit open, it'll appear in my toolboxes, web mapping. Now that I have a toolbox, I can start to create tools inside of it. So we'll do that. We'll create 2 tools inside of it. The first one's just going to be a simple buffer. The second one's going to be a buffer and a basically a buffer. Maybe it'll be an intersect. Maybe it'll just be a buffer and a select. Anyway, it'll be something like that. All right. You could really make it whatever you wanted. All right. So we got our web mapping, and I'm going to create a new model underneath that. Now, we could create a script tool in here too as well. If you've heard of script tools, it doesn't have to be a model builder, but creating a script tool, in other words, a tool that's created with a Python script, is bigger than this class. There's a whole class on that, the spatial programming. Well, it's not just on that, but it is on writing scripts for ArcGIS. My point here is that that it doesn't have to be a model, as in using model builder. It can also be a script. And I think that, in my personal opinion, once you get the model is straightforward, but once you get the hang of using scripts, that's actually it's actually easier, or at least it's quicker for me to use a script rather than model. So I don't use model builder too often, but it is very helpful for somebody who doesn't know programming at all. So this is a blank canvas. So this is a tutorial on model builder. This is a blank canvas here, and we can add other tools to the blank canvas, and they will run in sequence. So we can add buffer, and then we can add a select or buffer and a clip, and we can chain them together. So it'll first run the buffer and then run the clip. All right, and we can set the parameters that we want the user to be able to modify. So let's start with just the buffer. Okay? So I'm going to find the buffer tool. The buffer tool is under Analysis Tools and Proximity. And there's a buffer tool right there. I'm going to drag buffer onto my canvas that I've just created. So I've got buffer and I've got output there. So before I get too far, I'm going to save this, and then I'm going to close it. And I'm going to come down here to where it says model, and I'm just going to call this, I'll just call this simple buffer. I'm renaming it. Then when I call it simple buffer, rename it, I can go back in to edit, and it'll bring it back up. Now whenever I hit save, I'm saving it, and it's got its new name. So the first thing that I want to do is specifically notify ArcGIS, and therefore later ArcGIS server, what the inputs to my model are going to be. Right? So if I double click on buffer, you can see what the inputs to buffer are. The inputs to buffer are input features and the location where you're going to save it, and the distance where it's going to, how big it's going to be, and all of that other information. Okay? The side type, the end type, that's just how the buffer is formed. We're going to be buffering points, so those actually don't even matter. So if there's a line and you buffered it, would it be like a rounded at the end, or would it just be cut off? That's what that means. But we're just doing points, so none of these really matter, and they're optional anyway. So basically, we want the user to be able, the user of our service, we want them to be able to modify the input features. In other words, we want them to be able to specify, using a point click on the map, what the input feature is. And we want to be able to specify the distance, how big of a circle they want to get back. So we want to be able to specify those two things. Those are the two inputs. So in order to do that, this is the way you do it. You right-click on buffer, and you say make a variable from parameter input features. Okay? And then you do that one more time. Make a variable from parameter distance or value field. So that's what we want to do. Right? Is that me? Sorry. Oh, I'm turned down. Okay. Okay, but after we do that, we right-click and we say that we want to make this a model parameter. In other words, we want to make that something that the user specifies. And then with a dist, we also say that that's going to be a model parameter. Okay, it's actually distance. One thing that we can do is click on these things and set up default values, which is always a good idea, I think. All right. So it's set up to use linear unit, and we're going to drop down and we're going to change this from decimal degrees to, let's do miles. And we'll set 10 miles as the default value. Maybe we should use kilometers, right? We'll be international. We'll use kilometers. And we'll say 25 kilometers. Not quite the same as 10 miles. All right. So I changed that to 25 kilometers and I said okay. Notice that as soon as I did that, the color changes. What that means is that variable is ready to work. Okay. I'm going to do the same thing with the input. I'm going to one thing that I should do, actually, before I do that, I need to create kind of a dummy input for that. Okay, so I need to create a blank layer that's just points, and then create one single point so that it's like a dummy layer to specify as the drop down there. So I'm going to cancel this for a second, and I'm going to do that. So how do you create a new layer in ArcGIS? I think the easiest way is to go up here into the catalog button, and navigate to where you want to save it. I'm just going to use the same directory I've been using, which is CWM, and inside of there, I'm going to right-click and say new. Actually, I'm going to create a file geodatabase in there. I'm going to say new file geodatabase. I'm just going to call this, pin this. There we go. Going to make sure that this doesn't get too low. If it does, I'm going to have to delete some things. It's down to 6. Okay. All right. So I created that new layer there, that new file geodatabase. I'm going to rename it and change the name to web mapping data. That's good. And then inside of web mapping data, I'm going to create a new feature class. I'm creating a new feature class. I'm going to call this, I'm just going to call this point. It doesn't need to be very descriptive. It's just the dummy feature class for the user click. It's basically you're pretending this is the first user click so that you can run it and make sure it works. So instead of polygon features, I do need to change this to point features. Okay, and then I'm going to click next. And then here I'm going to specify WGS 1984 is 4326. This is just plain old latitude, longitude using the World Geodetic Survey of 1984. So that's what I'm going to choose. And that's fine. All right. Yeah, we'll accept the default resolution. Accept the default configuration keyword. Now here, we don't have to do one dummy field. Let's just see what they called it on this one. On this data set. So it looks like it says geometry type, attributes. No, that's the result. This one. It looks like it's just called ID here. Okay, so they added one extra field called ID. I think that's required in our GIS is that you have at least one user-generated field. So I'll call that ID and make it a long or a short integer. It doesn't really matter. I'm going to make it a short integer. It doesn't need to store a very large number. Right. And at that point, you can hit finish. And you've created your own layer, and it should show up here in our catalog. It does, point. Okay. Now the only thing left to do now is to actually create a point that's going to be the first dummy point. And so I'm going to minimize this or just move it out of the way, and I'm going to drag point onto the map. Or actually, well, it already created, it already put it on there for some other reason. So I'm going to delete it. Okay, so it's there. And if I go into editor and say start editing, I'll be able to create new features. I want to create new point features. So I hit point and hit OK. And then just click somewhere in the United States. It really doesn't matter where as the beginning point. So I'll click right here near St. Louis. Oops, didn't work. I need to go to the editor and say editing window, create features. There we go. Now I'm going to click right there by St. Louis. It's forcing me to use a vertex. It doesn't really matter since it's not. It doesn't really matter where I put it. So I put this little point right there. And now I can just say, editor, stop editing, save my edits, yes. So I've got my little point there, right near St. Louis. You can put it wherever you want. And now, at this point, I can update this for the input to be the feature class I just created. So that point data set. And now when I hit OK, it'll turn colors, and it says it's ready to run. It's ready for you to work. It's ready to work on the data. All right. So these are our two input parameters. This is the only process that is running, the buffer process. And this is the output. So this is where it's putting it for now. I don't think that's a problem. I forgot. Let's go ahead right now and say that we want to make that a model parameter as well. Why don't I remember? I'm pretty sure that we make this a model parameter as well. So let's go ahead and do that and say save. Okay. Now let's go ahead and run. I'm going to close this and close this. I'm not going to close our toolbox yet, but I'm going to close this other one. Now let's go ahead and run it and see if it works. So I'll just go model, run entire model. Okay, close. And if I right-click and say Add to Display, it's hard to see it. I'm going to have to zoom down in here. But there is the circle that it created. It's 10 miles outside. Remember we discussed last week why it's not shaped like a real circle. That's because of the distortion in the projection. And it changes. Some places it's very close to a real circle, and some places it'll be wider this way and a few places where it'd be wider this way, but we switched. It's a 25-kilometer buffer around St. Louis. So it works. Now, I said the second step was to run it. By the way, I said the second step was to run it, but you have to run it a different way than I just did. You actually have to close it and run it as a tool in order for it to work. So you close it up, say yes, you want to save it, and you actually have to go over here into web mapping. I'm going to delete point buffer here. Go over here in web mapping and say to run it again. It says that I'll just call this point buffer 2 when I run it again. It's just not letting me write over it. I'm going to say OK, and it's going to run it again and create the same thing. Now I want to create a service for it to run on the web. And the way that I can do that is to go under Results. And here it shows me all the times. I'm really trying to figure out why it does this on my laptop. But it makes it really annoying. It doesn't matter how big I make it or how small I make it. But you can see under current session, these are every tool I've ever run under the current session. And I've only run one using the toolbox. And so I have that right there. What you have to do, it's easier to see this on your computer, but you have to right-click on the result. Right-click on it, the one that says the name of the tool. In this case, it's Simple Buffer. Okay, you have to right-click on that result, and that's where you can say Share as a geoprocessing service. Okay? So that's where you create the service. Share as a geoprocessing service. And this kind of looks familiar to when we created geoprocessing or map services before. The first thing we want to do is publish it as a service. So then I'm going to hit Next. And, the service name is called Model. Let's modify that so that it's actually Simple Buffer. Okay. If anybody is actually working along, I'd like you to save the output into your folder. I'm going to save it into Raber, again, just so that we're not all creating a service that's the same name and writing over them. So I'm going to put it in an existing folder called Raber. You put it in your own folder if you're working along with me. If you're not working along with me, if you're planning to do this later, then that's fine. Okay, I'm going to hit Continue. And here is the place where I get to set up kind of the parameters. Okay. Now, one of the important things to look at is that there are two different types of services that you can create. This one that they've created is a synchronous service, and the first one we create will also be a synchronous service. The other type is called an asynchronous service. And essentially, they're almost the same thing. The only difference is that with a synchronous service, you send, or the client sends a request that says, okay, here is the operation I want you to do on the server. And then the operation gets performed and sent back, and the response is, here you go. These are the results. So the request is a request. In fact, asynchronous, synchronous is the same. They're both requests. They can be geographic data, they can be numbers. It's just a bunch of data. The difference is in the response. Synchronous service says, here's the results. An asynchronous service says, okay, when I'm done, I'll tell you. And, well, actually, I won't tell you. When I'm done, I'll give you different information. And so what you have to do with an asynchronous service is keep asking. So you have to write in your code, I sent you that request, and here's their number. You gave me a number. It's kind of like when you go in DMV and you get a number. Okay, so But it's unlike the DMV. It'd be really frustrating if the DMV was like this. You had to keep asking and say, hey, are you on 15 yet? Are you ready for 15 yet? You ready for 15 yet? No. Okay. That's the way an asynchronous service works, though, is you say, okay, this is the job I want you to do. They give you the number 15, and you have to keep asking, is 15 done, is 15 done, is 15 done, is 15 done. It's called polling the service, asking it over and over and over again. Why would you do that? It sounds more complicated, right? Well, the reason that you would do that is that if the process is expected to take a really long time, you could have it send an email or something when it was completed. Also, if it's expected to take a really long time, lots of web browsers will time out after about 15 or 20 seconds. In other words, if the process is going to last more than 15 or 20 seconds, most web browsers will say, I sent this request off, but I didn't get a response. So for longer running processes, they need to be asynchronous. This one that we're doing is very straightforward. It doesn't need to be asynchronous. So we're going to make it synchronous. That's under this one, under parameters. We're making it synchronous. All right, we don't need to view our results with the map service. The only reason why you need to do that is if you have a very complicated output that you don't want to send the data back, you actually want to send a picture of the data back. Okay. One thing that I always like to do is change the message level to, I like to actually change it to info. If you change it to info, any messages will come back from the server. So that way you can check to see if your service is not working correctly. So if you choose info, you'll send back warning, error, and info messages, any of the three. Sometimes you need to change this. We don't need to change it, but if there were more than 1,000 features that you wanted to return, you'd have to change that. You can usually leave pooling default. You can leave processes the default. Okay, here, though, is where you're actually going to specify what the inputs are going to be. Now, ArcGIS has figured out that we want, actually, this to be a user-defined value, the points. And the name of the input parameter, we've got it listed as point. For consistency, I'm going to change that so that it's actually input location, so we don't have to change as much on the... No, I'm going to leave that the same. We'll leave it as point so that we actually have to change our code. It'll give you a better idea of what we have to do. So that's one of the input parameters. It's called point, and it's a user-defined value. Okay. If you check include features, what it's going to do is it's going to have the actual point that we use in St. Louis as the default value. I like to do that, especially when I'm setting up services so that I have something to test with. All right, the distance or value field is going to be, we're going to leave that as a user-defined value. In other words, the user gets to choose that. Okay, the default value is going to be 25 kilometers. The output feature class is the result. And this is just telling us what the result's going to look like. We can leave that pretty much the way it is. I'm going to change this. I am going to change this one because I don't like the name to be so long. I'm going to change this to just output. In fact, I'm going to change distance to just distance. I don't like those long names. So we've got point, we've got distance, we've got output. Point, distance, output. Just so that we don't have such a long name for the result. The rest of this can be left as the default. At this point, I'm going to hit Analyze. Oh, wait. Nope. Nothing else to change. At this point, I'm going to hit Analyze. And let's see what what it's telling me. It's telling me that the output feature class parameter is missing a syntax dialog explanation of the description. I don't know if it'll let me publish that without that, but basically here under output feature class, it's asking us to put in a description. So we could just say the buffered result from the point. And then under distance, we could put the distance from the point you want buffered. And then the point, we could say the input point clicked, something like that. Now if we analyze again, those should go away. They do. Yeah, so it's just telling us that that relatively small point data set is going to get copied to the server. That's not a problem because it's so small. And the rest of this is, the rest of those are low. It's telling us that we're missing. I'm going to go ahead and hit publish. If you want to, you can too. And yeah, it's okay. It's going to copy that to the server. Watching the amount of hard drive space I have left. See if I can delete something real quick. Videos. Delete one of these old ones. How big are these guys? That one's pretty big. I don't know if that one got uploaded though. Might have failed. This one got uploaded though. Delete. These two are probably fine to delete. Okay. It's still working. Published. Okay. Recycle. I spell recycle. It's on the desktop, right? I'm just trying to empty my recycle bin. Oops. What did I just put? Okay. So now I have 26 gig GIS. So I created that, and now if I go to wmmaps.smap.org/rest and I go to Raber, I have my simple buffer GP service there. If I click on it, you can see my task. Oh, I made it asynchronous. I'll go back and fix that. So here are the input parameters. And notice that ours actually has the latitude and longitude for the default value included there. So it's a little different than the one from ESRI. So now if I hit submit job, it'll put that default value there. It's kind of nice. All right. Before I get any further, I'm going to go back really quickly and right-click on the simple buffer and share as geoprocessing service, and call this simple buffer. Oh, I'm going to go override an existing service. Simple buffer. And I'm going to change the under parameters. I'm going to change this to synchronous. Okay. Just because I don't want it to be asynchronous, because it's going to come back really quickly. All right. What else did I say that I wanted to change? Oh, it was the message level info. Okay, it left that already. So now I can just hit publish, and it should publish again. And when it does publish, it should now be a synchronous service rather than an asynchronous service. So we'll check that. All right. Now, while this is working, there are ways to do this in open source software, but they're a little bit more complicated. And I was going to include them in this class this semester, but I don't think that we have enough time. But basically, you learn the back end. So if you are interested in this, you learn the back end part as part of the geodatabases course. So if you're ever really interested in learning about open source geoprocessing, that's a good course to take, is the geodatabase course. And I might introduce that a little bit at the end of this, if we get through enough. Okay. So let's see if that changed. Right now it says asynchronous. I refresh. It changed into a synchronous service. Well, this time it didn't do the parameter. That's okay. I didn't tell. Oh, there it is right there. Oh, no. Yeah, it doesn't have the that input parameter there. It's okay. So notice that this is the one that was created by ESRI, and their parameter is called input location, but it is a GP feature record set layer. And if we look at ours, where did I put it? Ours is right here. I'll move them together. Ours is also a GP feature record set layer. Our name is point, their name is input location. The description is a little different. The direction, though, will be the same, ESRI GP input direction. The geometry type is an ESRI geometry point. Same spatial reference. Same spatial reference. The fields are FID, shape, and ID. Our fields are a little different. They're object and ID. And we have no features included. Neither do they. All right, so we're going to try to change their code so that we can feed it our input parameters and see if it works. Okay, so the first thing that we want to do is change the URL here. This is the URL to our buffer code. We want to go into their code and change this line of code here. Oh, by the way, let's go and save this as GP service 2, or yeah, about example, underscore example. So we want to change the URL to our URL. So instead of the drive time polygons, we're going to use the simple buffer polygons, and I'll upload this example once we're done with it. Okay, and we can leave this pretty much the same, except for our parameter is called point rather than input location. So we're going to change that to point. I think it's called point. Let me make sure. Point. Yep. All right. Now, here is the other parameter where it's a drive time. We want this to be the buffer distance. So we're going to change this. I don't like it how ESRI often changes the name of the parameter for you. So I'm going to take that. That's the name of the parameter that we have to feed it. So I'm just going to copy and paste it directly. Instead of drive times, it's called distance underscore underscore value underscore or underscore field underscore. With no, you don't want any extra spaces. Okay? And then the default value we have is 25 ESRI kilometers. I don't know how to. Let's just see if we can type in 25 kilometers. I don't know if that's. Did I spell kilometer? We don't deal with kilometers too much. All right, let's see if this works. Now the result is still going to be the GeoJSON, but the result's not called output drive time polygons anymore. The result is called output feature class. So we need to copy that down over here. Now we can hit save, and we can go back to our example here, except for we called it underscore example. And I'm going to click. I'm probably going to get an error, but okay, it's saying that it couldn't read output feature class, and that's because something happened. I'm pretty sure it's because of the units. It expects a different thing than the units in the units. So let's go to let's open this link. So it's unable to complete it. I'm pretty sure it's because we gave it a bad value here for the distance field. So in order to give it a proper value, let's see like what it's expecting by going back to this simple buffer, and we're going to hit execute task. This is what it's expecting. It's expecting this object. I'm going to modify that and put it in my code right here. So it's expecting a JSON object that looks like this. So now we should be good. So instead of saying 25 kilometers, we need to feed it a distance and a unit separately because that's what it's expecting. Last year when I did this example, I converted it to a string and it worked. But this is actually an easier way to do it because you don't have to do so much work in the model. But it didn't work out. Okay, so now it should work, but it probably won't. But let's see. Oh, it's working. Would have already said. Okay, so now we'll zoom out. That's a 25 kilometer buffer around that point, and that's a 25 kilometer buffer around that point. And that's now a 25 kilometer buffer around that point. Okay, so we're creating these buffers, and if we're looking at the network, we can see. Whoops, open link in new tab. We can see the result that gets created. So all these points are the buffer, the points around the ring. Because in ArcGIS, it's advanced, but actually one of the weaknesses in the data format, the shapefile and the geodatabase, is that it does not approximate curves. It only points. So any curve takes a ton of points. All right, so that's the result, and that works. All right, so that's creating a geoprocessing service, and it doesn't do a whole lot. In fact, we showed last week how you could do that same thing in turf. But now, what I want to do, and we'll probably do this after a break. We'll take a break here real quick. But what we want to do is click and have it return back the counties and the total population for the counties that are within 25 kilometers. So that gets a little bit more useful because, one, they don't actually have to have all those counties stored on the client, and we're doing a GIS operation. So we'll create a second tool that'll be just like our first tool, but it'll go one step further. We'll connect at least two processes together. So we'll put the buffer tool, and then next to the buffer tool, we'll put another tool. In fact, we'll need a couple of tools because we'll also need the tool that calculates the total population. Or maybe we could do that on the client. Yeah, we can look at that a couple of ways. All right, so let's take a 15-minute break and come back at about 6:30 and finish up that example, and then then that'll be that. Okay. I'm going to go ahead and stop this, and we'll pick it up. Part 1.